right, today guys, we're going to take a look at, we've been studying the different measures of center, mean, median, and mode. We discussed all the different measures of variation, where there was median, quartiles, IQR, range, and also mean absolute deviation. Now we're going to take a look at a deeper dive into the data. Using a data set, what would be the best measure of center? Are there times when mean is better than mode, or mode is better than median, or mean is better than median? We're going to be looking at that. And also what's going to affect a little bit is the outlier, so our measures of variation a little bit, and how that affects our numbers. So we're going to be looking at those two different ideas today. Identifying outliers and their effect on the measures of center. So really how extraordinary things change over all pieces. So the first thing we've got is understanding when to use each type. So this is our basic line we look at is the data. If we're going to use the mean, we're going to look for nothing with no extreme values. Okay, really what we're looking at is definitely no outliers based on the definition. And we're going to go with general idea of extreme as it's very wide range. We'll use the median when the data has extreme values, but there are no massive gaps in the middle. When the center of our data is relatively solid, yet our extremities, our edges, might have a little bit more change. And then finally, we're going to look at when the data has a ton of repeated numbers, that our mode might be our best measure of center. Because even then, sometimes we could have some extreme values that change our mode, change our mean and median to huge numbers. So let's take a look at what that would look like. So first thing we're going to take a look at is some data information to see which is the best measure of center. So I went ahead and copied this, and I'm going to put this in a corner over here for us to kind of use as our talking point. Let me stick it over here in the tiny section on top of our pencil, and say, okay, well, the first thing we probably ought to do is determine if we have some extreme values, because that's really the difference between and repeated numbers. So we look first at we have no repeated numbers. So if we're going to say that mode is best when you have massive amounts of repeated values, it's not going to be mode for this data. All right, so we're down to median, and we're down to looking at mean. So let's go ahead and, figure out a best way to, one of the best things we can do to figure out if we have extreme values is to go ahead and put the data set in order from least to greatest. That would also start us off easy if we have mean. It would help us, or median, and it would help us organize our thoughts for mean. So it's a good data point. So we say 97, 101, 103, 110, and 112. So I would say if I look at this, the difference really is only 15. That's our range of our data using a measure of variation that we know. And then going, okay, well, there's no real extreme data values. Everything's pretty core jump. There's no huge gaps in data. I'm probably going to say that our mean is our best choice. I mean, we quickly could figure out median. It's right there. We already have 103. But we'll probably say there's no extreme data values, so we're going to add all those numbers up and say, okay, what's my mean? Mean's probably my best measure of center here. And I went ahead and already did this, so you add up all the numbers, you end up getting 104 and 6/10 being the best average number. Okay? So that's going to be our best measure of center. Go ahead and pause the video as you turn to this next page. I'm going to go ahead and put out that chart for you again. Oh, didn't mean to undo that. Did the wrong button. I'll put our chart back on the corner for us. I want you to take a look and read this over and say, okay, which one do you think would be the best measure of center? Which one? Is it a mean, a median, or a mode? And then we'll pause it. Then we can unpause the video and figure out what it is. All right. Well, let's see. So again, let's use our basic starting points. We know mode requires repeated values. We have no repeated values, so it definitely can't be that one. We have mean and we have median as our choices here. So we take a look at that and go, okay, well, is there an extreme value? Well, let's check it out. Let's put our numbers in order from least to greatest. 207, 133, 1,231, and finally 1,332. 332. I would characterize that as an extreme value. That's a massive difference. So I would say that that's probably an extreme value. And with that extreme value, my best measure is going to be median. So together we'd find the median as 1,132. And that seems to be a pretty good measure. Without the 207, it kind of negates that 207's ability and says, okay, the center is probably closer to here. And if you look at these three numbers, that's probably a much closer measure of center with the majority of our data. And if I went ahead and did the mean as well on a previous calculation just to see what we have, and that's the difference for the mean and the measure of center. It would be greatly affected, and we'll talk more about this as we go farther in the lesson, is the mean is greatly affected by this 207. It drops our median from our median by over 200, almost 200, in this case, sea turtles. That's a big difference between the two. So we're definitely going to say our median, because of the extreme value, is going to be our biggest key here. All right. So let's take a look at this one. I'm going to have you pause the video. I'm going to go ahead and put back that chart again. And I want you to take a look at it and go, okay, what do you think this one would be? Let me stick our chart here in the corner again and say, looking over this data, what would you choose? Would it be mean? Would it be median or mode? All right. Unpause the video and when you have your decision. So we have mean, we have mode, and we have median. So taking a look at our data, again, I see this time I have 4 repeated data points. Now that's a majority of my data is repeated. So I'm going to say, honestly, I'm thinking mode right now is going to be the best measure of center because that's where a majority of my data lives. Over half the data points, that's a good breakdown to say that mode is probably going to be the repeated value. This has many repeated numbers. And because I am a little thorough at times, I went ahead and calculated the mean and the mode in the median, and you'll notice, look how close they are to each other. Remember how we talked about how close the data is, the more reliable it is? Well, it makes perfect sense. Look at how close my mean and my mode and my median are all within 0.3 of a degree. So, but definitely mode would be our best measure of center because it happens so often. All right, last one I want you to try. This time I'm not going to give you the chart. I want you to figure out which one you think is the best measure of center, mean, median, or mode. All right, so let's take a look at it. As we work on the problem, we notice automatically real quick that 12 has got a prevalent number set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of my 16 numbers in my data set are 12. So right away, your mind is thinking, oh, that's way more than half. Mode's going to be my best measure of center. Okay, and truly that is your best measure of center. So good job if that's what you came up with. All right, so now let's take a look at working on our outliers even more. Now remember how we talked about outlier? To find outlier, you're going to go ahead and say that it's the IQR times 1.5. So that changes a little bit. So if we have it, so we got to see now, first things first, I bet you can identify the outlier just by looking at it. You've probably figured out the Galapagos tortoise is the outlier, having a 200-year lifespan. But let's go ahead and prove it. So the first thing we'd have to do is do median so that we can get our Q2 before we can get our quartiles. So let's take a second and review that information while we're here. So we put them, let's go ahead and put them in order. So 200, so 20, 30, 30, 35, 50, 70, and then our 200. And you can probably tell that's definitely got an extreme value. So now we're going to look at here, okay, here's our Q2. Our median, our Q1 is right here. Our median is right here. And our Q3 is right here. So now I've got all the data I need. My IQR is 40. So 40 times 1.5 is 60. So I really have a range. My limits of for outliers are -30 and a positive 130 to 130. Those could be considered within a normal range. Now, obviously, that my quartile 2, that definitely our Galapagos turtle outside the range of our normal numbers is our 200-year-old Galapagos tortoise. It's definitely our outlier, okay? All right, go ahead and figure this one out and see if you can determine if there's an outlier in this case. All right, now, surprisingly, there is no outlier in this case. And one of the biggest reasons there isn't in this case is the data set is so small. So let's see what that does to us. So first things first, we put them in order 9, 11, 13, and 43. That's our data set. Our median would be right here at 12. Our Q1 would be right here at 10. Our Q3 is here, and this is what really shakes us up, is that our Q3 is 28. Or sorry, is it 28? Yeah, so let me look at my chart again. Yeah, it's 28. So that's a huge difference. That number is really affecting it. If we had one more number, that definitely would be considered an outlier. But then we have an IQR of 18. And then if you do 18 times 1.5, you get 27. And from our quartiles, you're talking negative 17 is outside the ordinary, all the way up to 55. So technically 43 is not within our outlier limits. It looks like it should, it automatically sees like it should, but that extreme value has a huge difference on our effect because it's such a small sample size. We're going to go ahead and say, yeah, it's an outlier, even though our mathematically doesn't improve it, but we're going to use it for a future question saying 43 would be considered an outlier. Okay? So now we're going to take a look at how the outlier affects the mean in mode. So we've already got our data for this. We have our 20, our 30, 30, 35, 50, 70, and 200. So to figure this out, let's just do a little experiment. Let's go ahead and find the mean, the median, and the mode. Well, I mean, the mode won't change either way. Okay? Our mode's going to be 30. It's our only repeated number for both times with and without the 200 in the data set. So if I have a mean of this one, our median would be right here, it'd be 35 with the outlier. Okay? Without the outlier, let's figure out what our mean is. So we go ahead and put all this stuff together. We find our median, let's go say 20 plus 30 plus 30 plus 35. Helps if I can type correctly on my calculator. Plus 50 plus 70 plus 200. 435 divided by 7. It puts our mean at 62 and 1400ths years. That's without our mean. So we take our 435 and we subtract 200. And then we're going to divide this time by 6. We find that our mean without that 200 in is 39 and 1700ths. And our median without that, we're looking right here in the middle, is 32 and a half. So let's just take a look and explore what that tells us about our data. And goes back to backing up that chart that we looked at earlier, this chart that said, hey, if it has extreme data values, why the mean is not the best choice. I'm going to bring this up over here in the corner again over top of our pencil. Look at the effect that mean, that the 200 has on the outlier. Okay, if 62 minus 39, it changes the average of our overall piece by 23 years. One animal changes that average. It changes our median by 2.5, and it doesn't change our mode at all. So you can see why, if we have extreme data values, a better measure of the center would definitely be our median, okay? Because it has a massive change on our mean, because the mean says that one number is almost half of our data. If it's only 235 divided by 6 over here, and this is 435 divided by 7, one number, one age range is changing our data 23 years. That's a huge change. And that's why that we want to avoid using the mean as our center number when we have extreme values. All right, take a second for this and do the same thing with this problem. We're going to go ahead and say 43 is going to be considered an outlier in this case. So go ahead and use that. Find me the mean, the median, and mode with and without the outlier. All right, pause the video and see what you come up with. All right, now let's say with and without. So let's see. So together, it has 76. divided by 4. So it has a 19 number of species as the mean here. Without that 43, the mean is 11. The median, we've already kind of figured this out in a previous problem, we said was 12. The median without that would be 11. The mode, well, there wasn't a mode either time. So it has no real effect on the mode. Extreme values has no effect on the mode is what we're looking at. But you can see it has a difference of 8 years this time. That one data point changes our mean by 8 points. Not as much our median, but our mean by a tremendous amount. So again, it backs up our theory why we don't want to use mean as our measure of center when we have extreme data values. All right, so now that we've kind of talked about both of these, we would determine what is the best measure of center of the data with or without the outlier. So we already figured out all of our measures of center, okay? And it's right back here, so I'm actually going to jump back to that previous question. We've done the math. It said, which one is our best measure of center? Okay? If we look here, without our data values, with the mean, we're really going to say the median. If we have that outlier, the median is going to be our best measure of center. But without that, we definitely would say without that extreme value, we're saying our mean is our best measure of center because it doesn't change that much. They're all relatively close to center. Okay? I want you to do the same thing. Which would be our best measure of center here, and which would be our best measure of center on the second without the outlier. And you've probably found the same information. Our median definitely would be our best measure without it, with the outlier, and the mean would be our best measure of center without the outlier. And they actually happen to be the same without the outlier. So we get a huge difference that we've really taken a look. So your job is to do the homework tonight. It's a little shorter than the last couple days, but that is a good break for Friday. So go ahead and finish up your homework with a time remaining. If you finish early, be sure to work on anything else you have from a teacher. If you have questions, please reach out. I'd be happy to help.